I didn't have this already recorded, so if I do, then I'll track just this recording of that. But today we're going to talk about measures of central tendency. Do you guys remember learning about mean, median, and mode a long time ago in junior high? I know I taught it to my junior high students. I'm sure that's about when they learned it, or I don't know. But we worked with it then in 7th and 8th grade math. But so we're doing that, but we can do more fun things with it than just 7th and 8th grade math. Okay, so you'll have some familiarity, that word, I think, to it, but then maybe we'll add some stuff on top of it to apply it to life, okay? So there's 3 types of averages that are statistical measures of central tendency. One is a mean. That's when we're going to add all the data values together and then divide by however many values there were. So if you added 10 numbers together, you get their total and you divide by 10. Your median is going to be the middle number when the data values are in order from smallest to largest. Now, if you have an even amount of numbers, that means you don't have just one single middle number, right? So you would just take the 2 middle numbers and find their average. So you add them up and divide by 2, if that's the case. Mode is going to be the value that occurs most often. Sometimes there's not a mode at all. And sometimes there's more than one mode. But it's not just because the number repeats. It's if it repeats more than the others that repeat, then that would be the mode for that set of numbers. So like when we look at number 1, what I always do is say it's really good to just be in the habit of putting your digits in order from least to greatest before you ever get started. You could wait till you got to the median because that's technically when that happens. So it has to be in order from smallest to largest to be able to find that middle number. So if you waited and you just started with mean, I guess we'll do it like that. That means we're going to add all these numbers together, and there's 1, 2, 3, 4, 5, 6, 7 digits, and we would divide by 7. So I'm just going to put the word total here because I don't really want to rewrite all those digits with plus signs in between it, because I know you guys can pick out your calculator, which I don't have mine with me today. I don't know how I left my office without it. Let me be right back. Just across the hall. To have it, but I do have it. So when you have your calculator, turn that off. I don't know if that's gonna help or not, actually at all. So we would just start typing in 180 plus 201 plus 220 plus 191 plus 219 plus 209 plus 186. So we get the total of 1406. And I would recommend always double checking, making sure you didn't accidentally flip numbers, type in a wrong number. But I do know that that's correct. So 1406 would be their sum. But then we would divide by 7 because there's 7 values there. So it's on my calculator. So I just click divided by 7. And I already wrote up here, I knew we'd need some rounding instructions added. We're going to round to the nearest hundredths. So if your calculator said 200.857, the hundredth is always your second digit. So we're trying to decide if 5 stays the same or if we round it up. And in this case, we're going to round it up, right? So this would be 200.86. Our median. So our median is where we need to put these in order from least to greatest. You kind of just look, see what's the smallest number. It looks like 180 is, and I would get lost, so I would cross through them to stay organized. 186 would be next. 191 is next. And then we have 201, it looks like. But really, it's just reorganizing the data. So a lot of times when you're working with stats, you're organizing the data in some way. It's not hard, just maybe sometimes a little time consuming. 209, 219, 220. So if there's 7 digits, that means the 4th digit would be the middle number, or you can just work your way through like this, and you can see that the median is 201. Another way to do that, if you, like, say there's 31 numbers, is just to take 7 and divide it by 2. It's kind of like you're splitting it in half, and you always round up, and that would mean like the 4th digit. If there were 31 numbers, just as an example, that would mean the 16th digit in the list would be your number if you didn't want to make your way from the inside out with your fingertips, which that would be fine. Your mode is the number that repeats the most often, and we had no mode, no repeating number, so there would be none for this one. Like I said, sometimes the mode is none. There were no repeating digits. I'm just going to put no repeating numbers. So there's no mode. And in WebAssign, actually, I think you put DNE for does not exist. So that's what you would enter. For me, you could say none, but WebAssign wants something specific, and that would be that does not exist. And just make sure it's capitalized DNE. So we get to do that with another set of numbers. So again, we're going to go find our mean, and that would just be adding all of those up. And then there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits, and we would divide by 10 this time. So instead of pulling out my calculator, is it okay that I just tell you the sum? I know you know how to type it in and push plus, so I'm just going to go ahead and do that. So when you sum all those digits, you're going to get 227. And then we're just going to divide that by 10. So that would give you 22.7 when you do that in your calculator. So we don't have to round that one. It's already at least an ending decimal, and it's in the tenths, not the hundredths. So we're good on that one. Our median, there are 10 digits, so we do need to go put this in order from least to greatest. You can't just go pick the middle 2 numbers in the order that it's given because it's random. So we need to go put it in order. I think 18 is the smallest. And then we have a couple 19s. And then we have 2 20s. And then we have no 21s or 22s, but we have 2 23s. Then we have a 24. And then we have 26 and 35 at the end. So if it's 10, that means we have 2 middle numbers that are going to be the middle area of this set of data. So if you take 10 and you divide it by 2, you would get 5. So 1, 2, 3, 4, 5. So that would mean the 5th and the 6th, the one right next to it, would be the other side's middle number, right? It's kind of like you have 2 numbers meeting together, or you can make your way in and there's not one single, there's 2. So you have to find the average of that. You have to say you're taking 20 plus 23 and dividing it by 2. It's kind of like you're finding the middle area between those 2. So that would be like 20 plus 23 is 43, and we divide it by 2, so that gives us 21.5. So the median is 21.5. So if it's an odd amount of numbers, you get the actual number that's right in the middle. But if it's an even amount of digits, so 10 is an even amount of numbers, right? Then that means you're going to take the 2 middle numbers that are side by side and find their average. Your mode is the number that repeats and repeats the most often. So I noticed that 19 repeats 2 times, 20 repeats 2 times, and 23 repeats 2 times. So since they repeat the same amount of times, one isn't above the other, basically. So we actually have 3 different modes. We have 19, we have 20, and we have 23. So it's not just one single mode, since they repeat the same. Now, if you would have had, like, say, 3 19s, so we would say 19 would have been the only mode, because it would have repeated more than the others, okay? So you guys do number 3, see if you can find the mean, median, and mode on your own, and then I'll do it with you here in just a second. So when you look at number 3, there were 6 digits in that set of data that they gave you. So that means when you added these up, you're going to divide by 6. So hopefully when you add it up, you got 20 divided by 6. And in your calculator, it would have been like 3.3 repeating forever and ever. So if we told you to round to 2 digits like we did up here, that would just mean you could have written this out with 3 numbers after, just like we did on the one above where we had to round the second digit would have been the digit in the hundredths. So we'd keep it the same and it would be 3.33 when you round. So I don't know if you guys remember, but first unit, I was like, rounding's gonna happen forever in this, right? And it really does. I didn't lie to you, did I? It happens forever throughout this entire class. Median, we had to put them in order from least to greatest. So you had a 1, 2, 3, 3, 4, 7. And because it's an even amount of numbers, you're taking 3 plus 3 and dividing it by 2. Basically, it's the same number, isn't it? So when you add it together and divide it by 2, you get the same number that was repeating. And 3 was the only number that repeated, so 3 was the mode of that set of data. So like learning that 1, 2, and 3 is one thing. These aren't real big numbers. The first one we started with were 3-digit numbers. Then we had 2-digit numbers and then just 1-digit numbers. But when you turn the page, we're going to actually apply it to something like a salary. So these are bigger numbers, but you're still doing all the same things. And so there's some questions in web assignment that are going to be a little bit like this. It's not always just random set of numbers out of order. Like this represents something. So it says, consider the following salaries for the executives of a certain company. So here are the listed salaries for different people in management or the higher management of the company. So if we were saying what is the mean, we have to add all of these salaries together and then divide by their 1, 2, 3, 4, 5, 6, 7, 8, right? So you'd have to take the total and divide by 8. So it's like 8 different people. We're finding their average salary between all of those 8 people in management. So you would have to go through and add all those together. And when you do, you're going to get 624,000 divided by 8. So again, I think you guys are capable of typing in 170,000, 140,000 into your calculator. And when you do, you might practice it yourself, you'll get 624,000. So then to find the average, 624,000, basically that means this company is paying this amount in total to all wages. But what if we evenly distribute it? That's kind of what average would mean to that. If we divided it by 8, that would be 78,000. If you could evenly distribute that salary budget, then everybody would get 78,000. That's what a mean or an average is representing. If you apply it to something in real life. Now, probably the president wouldn't love that, right? If they made $78,000, but that's what it would mean. Everybody in those management positions would get paid the same thing. So it would be evenly distributed between those 8 positions. Median would mean what would be the middle number. And what's great is it does have it in order from least to greatest, just in a vertical way. So if there's 8 digits, then that means my 4th and 5th would be my middle 2. So you could also count that, but you can see there's 3 below and 3 above. And that's going to be kind of like the middle number. It just looks different because it's vertically written instead of horizontally written. If we find the median, I'm going to label this, so I'm going to do it right here. If we're working with the median, we would take 54,000 plus 40,000 and then divide it by 2. So we would say 54,000 plus 40,000. And then we would just divide that by 2, which would say my median would be 47,000. Mode would be the number that repeats the most often. And it looks like I have 30,000 that repeats twice. And I have 40,000 that repeats twice. No others repeat or repeat more than twice. So we would have 2 modes. We would say 30,000 and 40,000 would be the mode. So when we apply it, it helps us kind of understand the purpose of central tendency. But so say you're this company and you're trying to hire the different measures of central tendency kind of target what you're wanting people to know basically about your company in a sense. When we're talking about salary. So like if I were to say the average salary is 78,000, well, that's a little skewed because there's a lot of people that make below 78,000, isn't there? So it might make them look good, but when they actually go and interview and they offer them money to say, hey, we want to offer you $30,000, you'd be like, whoa, but the average salary is $78,000. Where's that $40,000 on top of that, right? I mean, that's what my mind would think. Like I want to make the average. So that's why some measures of tendency are more appropriate for different situations than others. In my opinion, in this scenario, I think mode says more about this company than the others because most people are making 40,000 or less in that group of people, right? So I think that mode tells us more I don't really even think median tells us a whole lot because we just are finding a median between the higher and the lowers, but it's still much closer to the lower paid people. Those higher executives make significantly more money, which makes the average seem higher. That's what those numbers do for each other. So, I mean, that's why there's different measures of tendency and why you might use one over another depending on what it is you're trying to do. But if you're hiring and you tell people that your average is 78,000, people that come to apply are probably not going to accept the position because they're probably those people that already have jobs that make close to that. And then if you offer them 30,000, they're like, well, that was a waste of my time. Can't live off of that because they have a budget of a certain amount, right? So anyways, that's kind of applying it to help you think about how does mean, median, mode really matter in real world? Or it could matter to you even when you go apply for jobs and things like that. How many of you have looked up careers and to see how much that career made? A lot of us, yeah. I know my son does it all the time. He's like, well, I'm going to be a this because they make this amount of money. Like, that sounds good, but how much do they make in Oklahoma? Have you looked at that? You know, like, it can be really skewed just like this, depending on, like some state may pay way more for that job for some reason because they're in higher demand. You never know, you may need to move to make that amount of money. So, okay, and remember when we learned about frequency? So Monday, we learned about how we could simplify a list of data by making tally marks to say, actually, there were 4 number 1s in that set of data. There were 8 number 2s in that set of data. Who cares even what it represented, but that's what the frequency represents, right? But that's how many times that number appeared in that data set or set of data. And that's really what's happening here. You just don't see it that many times. If I were to make this list, that would mean that there would be a total of the frequency. So if you want to make a total, that means you would be adding these together. So 1 plus 3 plus 10 plus 5 plus 2 is 21. So that means that there would have been 21 numbers in this list. If you wanted to write them all out, you could. That'd be like saying 90 happened once, 80 happened 3 times. If you're a visual person, you could do that. You could write 70 10 times. You could write 65 and 52. But that would be really time consuming because the whole purpose, especially, is when you find your mean, you're going to need to add them all together. And so if we're saying 90 only occurred 1 time, what we could do is just take 1 times 90, and then we're going to add this list together to get our total amount of the scores here. So it says, suppose a class obtained the following scores. So 1 person got 90 points out of probably 100. 3 people got an 80, so we're going to take 3 times 80. So basically what we're figuring is the total points earned by the class. So 3 times 80 would be 240. Then we're taking 10 times 70, which would be 700. 5 times 60, which would be 300. And 2 times 50, which is 100. So we would add all of these together to get the total amount of, basically, like how many points were earned by the students. So when you add all this together, you'll get 1,430. And again, this right here was what we found there. There are 21 students or tests. Total tests. So to find our average, we're going to take that 1,430 and divide it by 21. So frequency just makes it look different. But if that really is hard for you to grasp, then I would say you should expand that list and go backwards. Okay. expand it, make it show the 21 numbers, and then all the other things will be the exact same thing that you've been seeing previously. It's just it would be a big list. So 1430 divided by 21 is 68.095. So if I said round to the nearest hundredth, like we usually do, I would actually end up rounding to the nearest tenth, wouldn't I? Because I'd have to round my 9 up, which would round that up. So this one would be 68.1. That would mean the average test score would have been like 68.1. I would assume that this would be, out of 100%. That's what the average test score would be for that class. What's the median? So that would be the middle number. So again, how many numbers are there? 21. So if we take 21 and divide it by 2, actually I'll put that here so you know what it went with. This would be one of those that it helps. We bump that up and we would say, since that's 10.5, we would say the 11th number would be the median. Now you don't have to have the whole list out if you don't want to find the 11th number, because I know the first number, second, third, and fourth, fifth, sixth, seventh, eighth, ninth, 10th, and 11th is probably going to land right here within the 70s, right? If you need to see that, then you probably should write them all down. But if it's the 11th number, there's already a couple numbers happening before that. It's probably going to land in the group of 70s. The last number will. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if the 11th number would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It would be a 70. So again, if you can't quite grasp that, write your list out. It will help you. It's just you have to write 21 numbers now. So the median is 70. What's the mode? 70. And how do we know that? That's the one that repeated the most right here. It had the biggest frequency. Frequency would be showing how often that repeated. Okay, so the mode would be 70. So that's all that the notes that we have for measures of central tendency. These notes help you a little bit through it because they have a couple examples that are similar. So you can refer back to them whenever you're looking at some that aren't in a horizontal list. Maybe they're in a vertical list. That homework really isn't due until Friday. So you don't have to do that. But what I do want to remind you of is, let's stop this.